Hello, so today we'll discuss about HPLC. It is high performance liquid chromatography. So now HPLC. So this is also we can also write another name for HPLC. Sometimes it's also called HIC. That is hydrophobic interaction chromatography. Hydrophobic interaction chromatography. So now HPLC here, this is basically like a reverse phase. So see, we have to, if I take talk about normal phase in chromatography, right? We have two phases, stationary phase and mobile phase. If we talk about normal chromatography, stationary phase is polar, or you can say hydrophilic. So polar basically is silica. And if I talk about mobile phase, that is non-polar. That will be opposite of stationary phase. So non-polar, that means it will be hydrophobic. Hydrophilic means like they love water, like positive and negative. Hydrophobic means they will like charges will repel each other, like positive they will repel. That is hydrophobic. If I talk about opposite, attraction, that is hydrophilic. Okay, so non-polar here, hydrophobic. So here non-polar we have hexane or chloroform. Now if I reverse it, that will become HPLC. So in reverse case, what will happen? Stationary phase will become non-polar. Another name we can say hydrophobic. And in mobile phase, that will become polar. That will be hydrophilic. So now here I am saying this stationary phase is non-polar. Now see, silica is comes under the category of polar, right? So now if I want silica to become non-polar, what I'll do? Silica is attached with carbons. Now now it becomes non-polar. Now if I talk about mobile phase, that is polar, so here I will add methanol to water. So this will become polar. So now what happens? Now here high pressure pump is used to push the sample. So detector is there, which so all when all this system is running, stationary phase and mobile phase, so all the molecules which are absorbed, which are not absorbed, that is done through a detector. So before that, now we talk about the interactions. Let's say if there is a hydrophobic and hydrophobic interaction. Its movement will be slow. Now, if I talk about hydrophobic and hydrophilic interaction, movement will be fast. So let's say if there is a stationary phase and that is hydrophobic. Phobic means, let's say it is non-polar. And let's say our sample, let's say our we have that now sample that is hydrophilic. Now if hydrophilic and hydrophobic, the movement will be fast. If another case, stationary phase is hydrophilic, or you can say polar, and on top of it we are pouring hydrophobic. Okay, one sec. Philic. Okay, let's say here we are taking hydrophilic. So now the interaction will be, since they are same, like charges, like philic, so interaction will be slow. In this case, interaction will be fast. Okay, now when the system is running, sample is passed, high pressure pump is there, solvent is there, right? So now these molecules, they are detected by a detector. Now first, this is a baseline, and this is just baseline means only this is just pure solvent, no absorption is there. Okay, no absorption is there, only just solvent is coming out. Then if you see a peak, that means a molecule is absorbed, like some absorption is there. Then again a plain line, that means this plain line means no absorption. Okay, here no absorption is there. So now if you see this thing, this is the area that this area is basically the quantity of that molecule. Okay, so this was about it. Thank you.